this year, we'll be merging our content offerings into a new unified creator marketplace called Fab. Built on the strong foundation of sketchfab.com, we're going to drop the sketch and go all in on Fab. Fab will be an open marketplace serving the entire digital content creation industry. That means we're going to offer assets for all game engines, all digital content creation tools, and metaverse-inspired open worlds. So whether you're a studio making a blockbuster game or a movie, or you're a player building your first island in Fortnite, our goal is to bring you everything you need to build your world in one place. We'll have 3D models, materials, sound, plugins, animations, visual effects, and more. Fab will be the new home of Quixel Megascans, MetaHumans, and other incredible epic content designed to push the limits of what's possible. We'll also bring you the high-quality assets and environment packs from leading art studios, AAA game developers, media companies, and even musicians who are taking fan engagement to the next level. But our primary focus is on bringing you the best stuff out there from millions of independent artists who will benefit from the lowest fees in the industry, pocketing 88% of revenue from their sales so they can build real businesses and invest in making more great assets for you to use. That's right. Now, with millions of assets, we have to make it super simple for you to find what you're looking for and get inspired along the way. We'll leverage automated tagging to consistently and accurately describe content, and we'll give you the ability to inspect 3D models before you download, making it easy to understand the game readiness of an asset so there are no surprises. Building on the success of Quixel Bridge, the Fab plugin will enable you to search, discover, drag, and drop content right into your scene without leaving the game editor. We want to improve your workflows by connecting Fab to all industry-leading digital content creation tools. For example, our partnership with Adobe will make it easy for you to export and publish models from Adobe Substance Painter directly to Fab. Finally, leveraging Sketchfab's digital asset management capabilities, Fab will be the place where you go to store, manage, and share assets either privately with teammates for collaboration or publicly on the web to showcase your work. And with collaboration tools like this, we want to help small teams do big things. Now, it's no longer just major studios who are driving our industry forward. World building has become accessible to everyone. And we're seeing this today with tens of millions of new creators building awesome experiences in Fortnite, Roblox, Minecraft, and other open worlds. This is increasing the demand for ready-to-use content, and it's creating an exciting new opportunity for asset creators to reach massive new audiences. We believe an open and fair marketplace where artists and developers can come together to buy and sell assets is essential to the creation of the emerging metaverse. Now, we're going to keep you posted over the course of the next several months as this rolls out, and we're looking forward to partnering with you all to make this an industry-wide success. And now, please welcome Sax Pearson.
It's great to be here today. We've been working towards this moment for a very long time. This next segment is exactly why I'm here at Epic, to move the industry forward and help make developers successful. I'm here to introduce powerful new tools to existing Fortnite creators, powerful new opportunities for professional developers. Fortnite is becoming an ecosystem. That means new tools to design, develop, and publish games, and a new economy that rewards developers. These updates bring us one step closer to Epic's vision of a connected metaverse where billions of players enjoy high-quality creations made by millions of developers. At the center of this all is Unreal Editor for Fortnite, available today in public beta on Epic Game Store. It's a new PC application that brings the power of Unreal Engine to the scale of the Fortnite audience, deeply integrated with the game with new workflows that allow PC and all other platforms to create together fast and fluid. We call it UEFN for short. But first, let's talk about how we got here. Fortnite changed when we released Fortnite Creative 4 years ago. Creative is an in-game toolkit for players to make sandbox games inside Fortnite. And because of Creative, Fortnite is already much more than a game. It's already a place where players find games and developers find players. But why should you develop in Fortnite? Well, our players are highly social, content-hungry, with over 500 million player accounts, massive PC presence, and the largest console player base. It's the best, most vibrant place for developers to find an audience quickly and publish new games. Islands built using creative tools already account for roughly 40% of playtime in Fortnite. That's billions of hours a year, and we expect that number to keep growing with UEFN. So this is a sample of games in Fortnite today. What we have noticed is that players are more engaged, they have more fun when they play Epic's own games, like Battle Royale, and community games made by creators like you. Like, the combination is what makes Fortnite special and what is going to help us all grow. As we've shown in Unreal Engine, Epic's mission is to deliver an awesome suite of tools for developers. Unreal Editor for Fortnite is for experienced game developers, like many of you in this room, but it's also for the growing community of Fortnite Island creators that are ready for Unreal Engine's proven PC editor workflow. As you're going to see in the demo coming up, UEFN and the existing creative toolkit is already a great combo for developer and Fortnite creator teams to make incredible experiences. Of course, our long-term goal is to make the entire feature set of Unreal Engine, or bring the entire feature set of Unreal Engine to UEFN, but also over time to expose many of the other services that Epic offers. Bill just announced Fab. Fab is launching today also inside UEFN in an alpha version. And products like MetaHuman will be coming to UEFN in the future to support your creative vision. For the next stage of Fortnite, and ultimately the open metaverse, we also need brand new tools that solve really hard problems. Interoperability, scalability, and resilience are real issues when you operate at this scale and expect this level of durability. This is what led us to develop Verse. It's a powerful new general programming language designed specifically for this purpose. You're going to see us use it in the demo in just a moment. The second thing we're working towards is high interoperability between UEFN and Unreal Engine that will enable you to take your work anywhere. And by the way, behind me is the new Creator Portal, also launching today, where you can manage all your islands, one-click publish them to the world, and when you publish to UEFN, your original IP and your assets are yours to take anywhere. Now let's take a closer look at UEFN features and workflows. We put together a short video, and then we're going to do a demo. Thank you.
Let's start with the basics. Unreal Editor for Fortnite runs on PC and is integrated directly with Fortnite, so you'll have access to over 4 years of content, all for free, to get you started. What's special about UEFN is what we call Live Edit. Live Edit allows anyone on your team to join a UEFN session from any platform that runs Fortnite. That means someone can join from a console using the normal Fortnite client, and they're able to work alongside and collaborate with PC users. UEFN has access to all Fortnite creative devices, our modular gameplay systems that work in the in-game editor. This allows you to instantly add gameplay and quickly bootstrap your game from the hundreds of gameplay devices already available. The UEFN beta has many of the same features we use to create Fortnite, including the landscape editing toolset. You can edit the landscape to change the look of your island, or make sweeping changes to create something completely new, and then quickly play it in-game to check out the results. So even though you have access to tons of Fortnite content, with UEFN you can make content that looks nothing like Fortnite. This is a section from Forest Guardian, a tech demo built in UEFN that we are launching today. A big feature of UEFN is the ability to import your own custom assets. So we used a few 3D models, textures, and materials that we built just for the project. And all the lighting in the cave was made possible thanks to Lumen, our real-time global illumination system. You can also find more content like Quixel Megascans and Sketchfab models in our initial alpha release of the Fab plugin for UEFN. All assets are curated and optimized for use in Fortnite, and the full version of Fab will launch later this year. You can also create and modify materials, so you can change the look and feel of objects easily. And you can import skeletal meshes, and then animate using Sequencer and Control Rig. Everything you've just seen is available today in the public beta version of Unreal Editor for Fortnite.
So it's a short video of just like the most condensed way we could show some of the more important workflows. But I think a much better way is to tempt fate, and let's do a live demo on PC running on Fortnite public servers right here on stage. Welcome Michael and Ray to the stage. Take it away.
You I'm glad that went well. All right. Hey, folks. So let's talk about how all this was made. Michael here has the scene open in Unreal Editor so we can take a closer look. For the environment, we built this level using Quixel Megascan assets, many of which are available in the Fab UEFN plugin. We also used custom content that we built just for this demo. For the gameplay you just saw, we hand-placed enemies using a creative device called a guard spawner, which generates the aliens that you saw at specific locations. However, we wanted to do more and introduce dynamic play that goes beyond what the current creative devices can do. So to do this, we used our new programming language called Verse. So in this short section of code, every second, we grab the position of the player. And for each spawn location, we then calculate the distance to the player. And if it's within a certain threshold, we tell that guard to spawn into the level. So now we have gameplay that's more reactive to the player's actions. This is just a short example of using Verse, but for a deeper dive, check out the Verse Tech Talk later today. Now, Michael is going to show us how we put the intro cinematic together.
Hi, everybody. So before the gameplay section, we played this quick cinematic animation. This was actually created entirely in UEFN using Sequencer. Sequencer is our multi-track editor, and it's been used in everything from in-game cinematics to Hollywood feature films. So let's take a look. Now all of this stuff is available right inside UEFN. So let's take a look at this last shot from a slightly different perspective. So the other thing we featured in this section was a bunch of Niagara. Niagara is now available in UEFN, and it's our high-end VFX system. So, and just like in the movies, you can frame up shots and have great effects. So what we're going to do here is just set this up. So just like in the movies, you can have slow-mo too. Makes everything better, right? So these are just a sampling of some of the stuff that you can do inside Sequencer. But let's get back to the game.
All right, so now that we're back in the game, in UEFN, you have access to Fortnite's time of day system. Or you could use what we did and do what we did and use a completely custom lighting solution. And thanks to Lumen, both daytime and nighttime look great. Now, let's go to the final gameplay section and let's close out the demo. But as a reminder, everything that you're seeing here was created in the same version of UEFN that we're releasing today.
I think I'm going to jump in here and help you, Ray.
I'm all for that.
Thanks, Mike. Thanks, Michael and Ray, everybody that put this together. The demo came about when we asked the special projects team inside Epic that came straight off the Matrix demo to, why don't you put UEFN through its paces? And one amazing fact about this demo is that it's less than 400 megs, it downloads and plays in less than a minute, and it plays on any platform that Fortnite runs on. Like, that is the promise of what UEFN is. So again, Unreal Editor Fortnite is available today in public beta in Epic Game Store. If you want an early glimpse of some other technical showcases that our internal teams made, with UEFN and verse, check out Deserted Domination, Forest Guardian, and The Space Inside. All three are available to play right now in Fortnite Discover. So we've talked about brand new tools and the Fortnite ecosystem. Now I want to talk about the next generation of Fortnite's economy that both Epic and creators will participate in. We call it Creator Economy 2.0. Here's how it works. The money in the economy comes from player spending in the item shop. Fortnite generates billions of dollars a year in revenue from player purchases. Fortnite players who have fun engaging in islands tend to spend more in the item shop. Creators who make popular islands are bringing real value to the Fortnite ecosystem, and we're going to share the resulting revenue with them. This is the engine powering a Creator Economy 2.0. We believe this so strongly, we will distribute 40% of Fortnite's global net revenue to eligible creators who publish games in Fortnite, both independent developers and Epic. Anything we make, like Battle Royale, Zero Build, also participates in the pool shared with creators. This will be the primary way that Epic will pay for our own game development in Fortnite going forward. This is I'm glad you feel it's a big deal, and I feel it's a big deal too. So, this is transformative and a big gut check for us too. We imagine thousands of third-party development teams building businesses and thriving with this model. Payments from the pool are based on performance of your island. We take into account data like island popularity, engagement, retention, attracting new players. And the benefit of this new approach is rooted in player fun and rewards everyone's creative work, both yours and Epic's. There's no need to design cunning monetization loops or extractive gating items. You make an island the players love. That is all you need to be part of the new economy. Creator Economy 2.0 is live right now. For eligible creators who are currently publishing, we are backdating the engagement payouts to the beginning of this month. And for more details and to sign up, go to create.fortnite.com. Everything you've seen today represents Epic's biggest bet ever. The release of advanced tools that publish directly into Fortnite on PC, console, mobile, and cloud, lowering the barrier for developers to be part of one of the biggest entertainment ecosystems. We welcome anyone to join us in the future, where original content is owned by its creators, where developer earnings are a function of fun, and where ecosystem can be directly linked through community language standards like verse. So to support developers who adopt UEFN, we're broadening the Epic Mega Grants program to help teams bootstrap projects that use UEFN and verse. We're just getting started, and we hope that you'll join us and help shape the future of development. Now we're going to give you a look at what UEFN can do right inside Fortnite. After the video, Tim is going to come back out to talk about Epic's future vision. Thank you very much.
Thanks. We think this is going to be a really powerful combination, putting together Fortnite's 70 million monthly active users with the power of the Unreal Editor and a new creator economy to share the revenue with creators who create engaging experiences. And it's another milestone on the path to a new kind of entertainment medium, which science fiction literature calls the metaverse. Because there's a crazy amount of hype around this whole topic, I'd like to step back and take a long-term look at what we see here. And at the core of it is some very real growth, starting with Fortnite's 70 million monthly active users, Roblox's 250 million monthly active users, Minecraft's 100 million, and PUBG Mobile and Apex Legends, and numerous other metaverse-inspired games, is leading to an identifiable audience today of over 600 million active users in these virtual worlds. And it's on a growth trajectory that will put it at billions of users by the end of this decade.
And so we can set aside the crazy hype cycle around NFTs and VR goggles. These technologies may play a role in the future, but they are not required. This revolution is happening right now. And the core of it is something that every gamer already understands. It's you and your friends getting together online and going around as a group on voice chat, having a fun time, and social entertainment experiences. And some of these experiences are serious games like Battle Royale. Some of them are going to a concert and dancing, or chatting with friends and just having a good time. We see this as the next big change in gaming and in Epic's evolution as a company. We started out back in 1991 making 2D games. We recognized the opportunity with 3D, so we built the first Unreal Engine and the first Unreal Tournament game. We evolved to make console games like Gears of War. Then we evolved to make online games like Paragon and Fortnite. But when Fortnite shipped first in 2017, it was just our game. But over time, we recognized the opportunity to bring it to a much wider audience. So we built Fortnite Creative Mode, and then the Unreal Editor for Fortnite coming out now. But we see the future of this medium primarily not about Epic's work, but about the work of independent creators. And we're building towards this open metaverse from two different directions. First of all, we're taking the Fortnite audience we have and enhancing the development capabilities with the new tools and this creator economy to support everybody's work. But we're also helping developers building standalone products evolve towards building metaverse experiences themselves. And the Unreal Engine is a tool for this. The Epic Games Store is a distribution vehicle for it. Epic Online Services has taken Fortnite's and Epic's 700 million player accounts and 5 billion social connections and opened them up for free to all developers so they can plug into voice chat and participate in these social experiences in a very easy-to-use way. And all of these are on-ramps to the future metaverse. We really think that over the next decade, today's separate apps and ecosystems are going to join together to form tomorrow's open metaverse. And because the last couple of decades have been about walled gardens, walled gardens, walled gardens, let's back up and talk about how open systems have successfully come about in the past. This last happened really big time back in the early 1980s and 1990s when the open internet was built. Back in those days, there were a bunch of closed networks at different companies and universities that couldn't talk to each other. And so the industry got together and defined open standards to connect these closed networks into one big open network. They connected email systems by putting the @ sign in email addresses so people on one service could communicate with people on other services. And then they began to define open standards like JavaScript and HTML for the open internet so that any user could participate. And the rule at that point was that any company could connect as an equal into the system just by following the open standards. Now let's talk about what this means for the open metaverse of the future. We have the opportunity to take all of these different online ecosystems for gaming, like consoles and publishers, and connect them together into a single place where anybody can talk to anybody else. We have the opportunity to turn today's game engines into tomorrow's metaverse browser engines. If you take a look at Unreal Engine and Unity and Godot, you have some very powerful 3D engines that have an increasingly common set of features and are increasingly adopting industry standards as ways of communicating with each other and with other tools. There's the GLTF content standards, there's Pixar's universal scene description format, and then there are a lot of new standards bodies that have formed to help to standardize the metaverse. There's Kronos Group, there's the Metaverse Standards Forum, there's the Academy Software Foundation and the Open 3D Foundation. And we have the opportunity for all developers to work together to define the future of this thing. And there's also the opportunity to connect the economies of these different ecosystems. What a user would really like is to be able to buy a cool-looking outfit in one place and take it everywhere they go. And as we were designing this new Fortnite creator economy, one of the things we were constantly thinking about is how this could, in the future, be connected into an open metaverse economy. And there's no reason that the core model there, in which revenue from item shops are shared with creators of experience based on engagement, couldn't be turned into an economic model for the open metaverse at large, with economic peering overseen by governance groups to make this work in a safe way for all players. And this gets us to a really key question here, and that is, who is going to build the metaverse in the future? And we believe the answer has to be all of us together. It has to be a combination of indie game developers together with AA and AAA game developers, and Fortnite creators and Minecraft creators and Roblox creators, each bringing their best specialized knowledge to the new world. And brands like Disney and Ferrari and Ralph Lauren have already experienced the metaverse through crossovers with Fortnite. We think this is just the very beginning of a very long-term opportunity for all of these companies to have a much larger presence in the digital world, in which it becomes a major and first-class business line for all of them. Future open metaverse will be about musicians and music labels and film and television studios who are using virtual production today to build world-class photorealistic content, being able to bring it and launch it playably in the metaverse, timed together with their film and television experiences in an endless stream of awesome entertainment content that's open to everybody to participate in. Now, Epic has a long history of supporting developers this way. We've built a lot of different services that are available to everybody to use. There's the Unreal Engine. There's Epic Online Services, which are open to all platforms and all stores. There's the Epic Games Store, which is open to software built on all engines using all different online services. And we believe the metaverse has to be open. It can't be another monopoly's walled garden. And Epic is all in on this. We went from the pandemic to the tech downturn, the crypto implosion, and now banks are failing. And it's a really crazy time again, but we're investing very heavily in the future with the belief that companies who invest now through these hard times are going to come out the strongest company in the future, the strongest companies in the future. Some of these investments we're making in Fortnite initially and then bringing the work to Unreal Engine. Some things we're building in Unreal Engine, taking to Fortnite. But the aim is to support everything that AAA game developers are doing today and more. And this project, to build this all out into an open system, is going to take most of the decade. And that is the journey from Unreal Engine 5 to Unreal Engine 6 that will happen over this time period. It is the same journey to the open metaverse. But there's no need to wait because we're doing it live. We're building all of these systems and deploying them as we build them right into Unreal Engine 5 openly with partners. So we hope you'll download this stuff, download Unreal Editor for Fortnite, download the Unreal Engine and get started, and come see some of our tech talks where we talk about this in way more technical detail. So thank you very much for your time.
much greener than we live.
An ancient horror has awoken from its slumber and is hungry for blood. You keep lookout.
Look out for what?
Peeps of the war zone have uncovered what appears to be an underground storage facility.
It's the game that no one ever thought was going to exist.
We like doing all sorts of things that are not common. Depending on the layout of the engine, that can be very difficult.
Having made games for 20 years, I almost feel lazy in the amount of polys I can push through this engine and still run fast and efficiently.
Double Fine Productions has been around for 20 years now. We're here in San Francisco, California. We're about 70 people. We started making our first game in 2000, which was Psychonauts, our flagship IP. And we just made a sequel to that now. So that's the 20-year history in a little bookended nutshell there. Teeny bookended nutshell.
Beware the cows! Not all milk is enriched!
Psychonauts is a very special franchise for Double Fine. We learned how to make console games making that game, and a lot of the same team is still here 20 years later.
You'll need one of these.
Now we're talking.
It's kind of our legacy, to be honest. It's this strange game that would not normally get made, but we made it, and it's kind of the soul of the studio.
Bacon. It's very, very important to the identity of the company, and we obviously took building a sequel to it very, very seriously.
The only reason we wanted to make Psychonauts 2 was because there are people out there who love Psychonauts 1. And so we knew that that group was watching, and we couldn't get the spirit of the Psychonauts wrong.
We wanted to make sure that we maintained the original feeling and character that the original game had, but at the same time, it was really important for us to modernize kind of how the gameplay felt.
Unreal was a good fit for Psychonauts 2 because it checked all of the boxes that we needed to check on the art side for sure. Allowed us to quickly iterate on levels and build a massive game with a pretty small team.
The Unreal Engine gives us a really robust content pipeline that allows us to tackle all kinds of different things from gameplay to visuals, and allowed us to focus on adding new things and not have to deal with basic rendering functions, which if we were rolling our own engine, we would have to worry about.
Here goes nothing.
It also provides a lot of extensibility to the programmers. With full source code access, we can go through and modify anything that we need to, add any new features that we need, which given the kind of setup that we have for a game like Psychonauts 2, there's lots of custom stuff that we're messing around with.
One thing that was a boon to us is that we took the spline mesh actor and we made our own version of it called the multi-spline mesh actor, which allowed us to take a statically built object and organically populate it through the world based on a spline. If we hadn't had that bit of technology, there's no way we would have been able to make enough content to fill this game, and we wouldn't have been able to do that without Unreal Engine.
One of the things that's really helpful about Unreal is that using Blueprint, designers can mock up an idea for gameplay and see if it's fun or not before they actually request a feature to be coded by a programmer. So we can do a lot of experimentation, which is always good to test out ideas in a rapid way.
It's really nice because it acts sort of like as a common ground where designers, artists, and programmers can all contribute to logic that's stored in Blueprint.
Like a lot of studios, we had to deal with shipping a game in quarantine. I mean, I feel really fortunate to work in the games industry because we were able to work that whole time. A lot of people couldn't work during quarantine, but we could keep going, and we ended up shipping Psychonauts 2 from our homes.
Having full source code access was really, really important to us because we were able to quickly develop this custom application that we used in order to synchronize drive data cache when everyone started working remotely. And so being able to distribute that work across a lot of different machines saved up a lot of time over the last year and a half.
Having all of our files be in sync was the thing that helped us the most. Just having source control on this project was the only thing that kept us going. Without that, it would have been madness. Yeah, we wouldn't have been able to make this game without it.
Ew, the slime is so sticky.
After all we've been through, the ups and downs, it's been quite a roller coaster. And then to make a game that's been so well received at the end of that 20 years, it just feels really good because it feels like we, I don't want to say still got it, but maybe someone, we'll pretend someone off camera said that. Oh, still got it? Yeah, that sounds good. Still got it.
Earlier this year, we released Unreal Engine 5, making the next generation of real-time technology available to the public. We've created many new tools and features that make working in real time faster, more efficient, and more collaborative. Let's take a look at a few of the tools in Unreal Engine 5. First off, you can create games and real-time experiences with massive amounts of geometric detail. By using nanite and virtual shadow maps, UE5 can intelligently stream and process only the details you see. Each of these buildings are film-quality, multi-million poly assets dropped directly into the level. Thanks to nanite, we don't have to bake details into normal maps or manually author LODs. And to display these assets in their best light, we've developed a fully dynamic...
Hey guys, my name is Julien Leroux. I'm the lead tools programmer in the Unreal Engine procedural team, and this talk is new tools for building photoreal worlds in Unreal Engine 5.2. So, sorry, double click. Let's start with PCG Framework because that's the thing I work on. So, what is PCG Framework? It's a fast and iterative procedural content generation framework in Unreal for world creators. So basically, we're trying to provide you tools so you can build your own solution for whatever procedural thing you want to do in your game, your movie, or any kind of project. So why are we here? Well, as you might know, in UE5, we released World Partition, and that allows you to build bigger worlds. And with bigger worlds, you need more content. And procedural is a pretty good way to approach that problem. So that's exactly what we've done in the Matrix Awakens demo. We've built this incredible city, all procedurally done, and it was awesome, right? But we kind of noticed there were some, production challenges, workflow issues that we wanted to try to address. And as you might have heard just a couple of minutes ago, with UEFN, more and more people are going to have their hands on UE, and we wanted to make procedural content generation a lot more accessible. So all of this drives the vision of what we're trying to accomplish here. We want procedural content generation in Unreal Engine, so no reliance on external processes, even though, I mean, you can add them if you want to. Runtime and live editing focus, so you can use procedural content in your games at runtime, or at least have a very good iteration speed in the editor. Because it's procedural and deterministic, you're going to have non-destructive workflows, and you're going to be able to do manual interactions, as you've seen in the demo. And finally, it's a framework, right? So it needs to be easy to extend. And we'll dive a bit more into that later. So the overall concept is nothing very new. Looks a bit like materials. Like materials, you have materials, material instances, and material graphs. So we're starting from the bottom here. We're introducing a new thing called the PCG graph, which I'm going to talk to you about in a second. At the instance level, we have the PCG component, well, it's basically the graph you want to run, and at some point in the future, some parameters so you can tweak. And somewhere in the future, we're expecting to have, what you see is what you get assets that you drag and drop, you have a couple of sliders, and it just behaves the way you would expect it to. So let's talk about the node graph. It's an editor like, maybe something standard like the material editor. You're able to drag new nodes, drag pins, or in your right click, add something. There's a node palette on the left side, which will actually show the nodes you've created yourself if you want to. You have the settings on the right-hand side in this case, where you can tweak whatever you want. And because it's procedural, you want to be able to see the results. So any node you can inspect, see the results, the properties, the points, the metadata. You can also turn on visual debugging, so you can show cubes or whatever mesh you want. But as you might have seen already, everything is interactive. You change the parameter, it shows up live. You add a new node, it shows up live. You remove something, it shows up live. You can also change the landscape, and it'll update. So it makes for a very interactive experience, and it's very useful, and hopefully you guys will like it. So let's dive in a bit more on the data side of things. So conceptually, in PCG, data is a probability density function. So that means that you're going to expect density values from between 0 and 1. So let's take one example, the landscape here, right? If you're on the landscape, density is 1. If you're outside of the landscape, density is 0. To take another surface example, well, if it's a texture, well, density can be driven by the pixel color, for example. So you can have values in between 0 and 1. That mathematical approach enables you to do intersections, unions, differences, interpolation, and be able to be very precise on exactly what you want to do. Concretely, we've already mapped a couple of engine types to be able to use in PCG. So landscape, you can raycast against the physics or overlaps. You can use splines, landscape splines, any kind of volume, primitives, collision shapes. But most of these you'll end up sampling from, and then you end up with points. And points are the core data type in PCG. So basically, points are very simple things: transform, bounds, density, and then some metadata. And metadata is what you're going to use, well, attributes, to build logic in your graph and come up with something cool. On the node side of things, the nodes basically, they do one of either two things. They do transform data, or they spawn or create artifacts, so spawning meshes, spawning actors, or any kind of resource you want to track. And PCG is going to help you to track those and manage those transparently. Of course, on the nodes, you can set up whatever value you want. Like this is a transform node, so you can say, OK, I'm going to change the rotation from minus 45 degrees to plus 45 degrees or something. But maybe more importantly, in native nodes, if you tag your properties as overridable, you can easily have the pins. Well, it's automatic, actually. You're going to have the pins so you can dynamically drive those values in the graph. If you're using a node created from a blueprint, any instance editable variable also will create those pins. And those pins will allow you to create logic and, in between the different data types or data in your graph. So let's say you build some trees. Maybe you want to put the roots around them, right? So you want to keep them in a logic way in your graph. Right. We're already providing you a small library a bit more than 40 native nodes. But maybe more importantly, we're still providing you with blueprints. And that kind of ties in the next slide, which is extensibility. At the moment, it's very easy for a technical artist, or even less technical artists, to build a blueprint node for PCG. You derive from the PCG blueprint element class. You implement the execute with context method, and then you can use one of the loops we provide you if you need to loop on some points. And this loop is going to be multi-threaded by default. You just need to implement the body. And that allows you also to not only be quite faster, but sidestep some of the blueprint limitations, like the number of iterations. But you're still in Blueprint, so you have access to everything in the engine. All right. On the execution side of things, I've already told you the nodes can be multi-threaded, and that's true. The graph itself can run multi-threaded as well. If multiple nodes, their inputs are previously computed, well, we can run them in parallel. But maybe a bit more importantly, for runtime purposes and live editing, everything can be time sliced as well. It's pretty simple to do. And it's something we can expand on in the future as well. And that's very useful for, for games that want to do runtime generation. Finally, we have a cache to allow iterations very quickly in the editor. So if you change just a part of the graph, well, we don't need to recompute the rest. It's already computed once. We've cached those values before. All right, so all of this is exciting. Hopefully, you guys are excited as well. But this is experimental 5.2, right? So don't get too attached to the UI or the API. We're still working on these. But we want to try to make these as simple as possible. So we'll streamline the APIs. We'll extend more stuff. And there's a couple of big topics that we're going to work on in the next couple of months and the next couple of releases. The first being graph LEDs. And JS will give you a good example and a good justification of that a bit later. We'll look into GPU microscattering soon enough, and we need to address a couple of production things, like per platform settings or different workflows. Sometimes you'd want to bake everything to the final game or something. But that's it for me. Hopefully you're still excited, and I'm going to leave you in the hands of the very capable JS to talk to you a bit more about the path we've taken to get to the Electric Dreams demo. Thanks a lot, guys.
Thank you, Julien. My name is Jean-Sébastien Gay, and I'm a technical art director working with the Unreal Engine development team on procedural and world building. We started working on a PCG framework just about over a year ago, and we were able to build the Electric Dreams demo that was presented earlier in the keynote by leveraging all of the groundwork and internal prototypes that we did throughout that development year. So let me start by showing you some of the most important ones. It was clear for us that the framework had to support runtime and live editing. We started by doing gameplay prototypes in the Lyra Simple project, as we think that there's nothing else quite like games to prove the point. As you know, in-game means unpredictable player input. And that's cool. That's what we want. That's what we love about games. But our procedural framework needs to answer to that with predictable, deterministic, procedural outputs. And that's extremely important. To test that, we built two simple prototypes with different variants for each. The first one combined control point mechanic and PCG. When a team captures a point, we spawn visuals around it, as well as new extra control points. Expanding the gameplay area up to a defined grid size. The team controlling more than 50% of the area wins. The second prototype is an infinite runner, where a single difficulty variable is incremented every time a player crosses a tile. This variable is then impacting the results of the upcoming tile, by increasing the density of what's coming up. And we made also a quick alternate version by adding a random rotation to those tiles. And then we updated the PCG graph to have arrows indicating where the player should go. And that was done fairly quickly. Actually, these multiple prototypes were built under 2 weeks by only 2 technical artists. And it allowed us to confirm that having that framework working at runtime within Unreal Engine for in-game and multiplayer content is an idea totally worth pursuing. Ultimately, we think that this framework can bring new gameplay opportunities for game devs. Next, we wanted to attack scale and speed in a much higher density in a large world. The demo was about switching realities using Fortnite, City Simple, and Quixel content. Here in the video, you can see the Fortnite variants being generated live during gameplay. It is made of 4 different PCG rules. It is made of a single PCG rule with 4 different presets. And they're applied when the player goes through those portals. To achieve this, we had to build a custom hierarchical generation logic in Blueprint as a way to support level of detail based on distance and orientation from the player. This hierarchical generation concept is to be implemented natively in the framework in the very near future. As with the gameplay prototype, this was all running at game time in a quick build, without any pre-generation during the quick time. Working on these really helped us on improving performance, multi-threading, scale, and parameterization. But, well, that's not all. We had to build well-building tools prototypes. We want this framework to be used by artists and designers to create their own tools for their own project needs. It's an open framework. It is not limited to a single task or domain. In this video, you can see the interrupt with the geometry tools to separate biomes using volumes, which are then processed within the PCG graph. But we obviously had to try some building generators, or it would not have been called PCG, right? So the first one here shows handles to define the footprint of the building, and then construct it using City Simple City Simple nanite modules. The second prototype here is a little bit more involved, as it's reproducing the concept of a defined grammar as used in the Matrix Awakens buildings. For each floor, the grammar is set within the node graph in this case, and adapts to the spline driving the footprint. So after seeing the great assemblies that the Quixel team was producing for this demo, we thought that it was a good opportunity to start looking about how we could be leveraging and crafting and procedural all together. We started working on what we call the PCG assets that can be used inside as instance nodes within the node graph. These assets basically stores a point cloud of all visuals contained within a level, with a full set of attributes, such